stability analysis. Let us first I will give brief introduction of stability analysis in S domain. S domain lo stability ఏ విధంగా క్యాలిక్యులేట్ చేసామో ఒకసారి రిమైండ్ చేసుకుందాం. So for the system to be stable, the stability condition ante enti? For bounded input, output should be bounded. For bounded input, output should be bounded. In S plane, for stability, all the closed loop poles, or you can say roots of the characteristic equation. All the closed loop poles or roots of the characteristic equation should lie must lie in the LHS of S plane. In the LHS of S plane. See, this is the S plane. So if the poles are in the LHS of the S plane, system will be stable. If the poles lie in the RHS of the S plane, system will be unstable. Now coming to the imaginary axis, if they are simple poles means not repeated. Suppose ఇక్కడ ఒక pole ఉందనుకోండి. They are distinct, ఒకే place లో లేవు. So then it is marginally stable. Suppose if they are repeated roots, ఒకే place లో multiple roots ఉన్నాయనుకోండి, repeated roots అంటాం వీటిని. So if they are repeated, unstable for repeated, and this is marginally stable for simple. So the same concept holds for at origin also. If multiple poles are there at origin, it is unstable. Only simple pole is there, then it is stable. Multiple poles unte unstable, simple pole unte stable. Left side unte stable, right side unte unstable. Right? Now coming to the jet plane. So how the S plane is mapped into a jet plane? This imaginary axis is mapped into, last class lo chusam manam. How the imaginary axis is mapped? It is mapped into a unit circle. Right? Now, in left hand side, this one, interior of the unit circle. That means all the poles should lie in the unit circle for stability. It means for stability, all the roots, this is the stability region. All the closed loop poles should lie in the interior of the unit circle. Suppose if any pole lies outside of this unit circle, system is going to be unstable. Unit circle ki exterior lo ganaka unte, bite unte unstable avutundi. So unit circle meeda unte, suppose a simple pole is there on the unit circle, then it is marginally stable. Suppose repeated, ఒకటే place లో రెండు poles ఉన్నాయి, then it is unstable. Same concept, imaginary axis మీద simple అంటే unit circle మీద simple. That means let us write the condition for stability in jet plane. For stability in jet plane, all the closed loop poles must lie in the interior of the unit circle. Right? For stability in jet plane, all the closed loop poles must lie in the interior of the unit circle. So any closed loop pole outside the unit circle, makes the system unstable. This is the second one. First దాన్ని కొద్దిగా తిప్పి రాసాం అన్నమాట. Right? నెక్స్ట్ మార్జినల్లీ స్టేబుల్ గురించి కూడా రాద్దాం. ఇఫ్ సింపుల్ పోల్స్ ఆన్ z is equal to 1 అంటే యూనిట్ సర్కిల్ అండి. ఇఫ్ సింపుల్ పోల్ ఆన్ z is equal to 1 it is marginally stable. మార్జినల్లీ స్టేబుల్. అదే మల్టిపుల్ పోల్స్ ఉంటే multiple poles on z is equal to 1 makes the system unstable. Makes the system unstable. Makes the system unstable. That means for the system to be stable, all the closed loop poles, that is the roots of the characteristic equation, should be inside of the unit circle. Should be inside of the unit circle. That is the condition for stability. Now to investigate the stability, what are different methods? In S domain, what are the different methods? S domain లో స్టెబిలిటీ చెక్ చేయడం కోసం RH క్రైటీరియన్ చేసాం, రూట్ లోకస్, then board plot, Nyquist, these four. So these are three are the graphical methods and this is the simple method RH criterion. Now in our Z transforms or in Z domain, we will do only two topics here. That means one is the root locus plot. Out of these three, we will do only root locus. And similar to this RH criterion, there is a criterion in the Z plane which is known as jury. Jury stability criterion. Jury stability criterion. Jury stability criterion or jury stability test. Jury stability test. Now let us do that test, how it was done, right? Jury stability test. Jury stability test. జాగ్రత్తగా వినండి. ఈ ఫోర్త్ యూనిట్ లో ఉన్నవి రెండు టాపిక్స్. ఒకటి మ్యాపింగ్ బిట్వీన్ ఎస్ ప్లేన్ అండ్ జెడ్ ప్లేన్ ఒకటి, రెండు ఈ స్టెబిలిటీ గురించి ఒకటి. ఆల్రెడీ హాఫ్ ఆఫ్ ది యూనిట్ ఈజ్ ఓవర్. మ్యాపింగ్, డిఫరెంట్ లోసై, కాన్స్టాంట్ ఫ్రీక్వెన్సీ, కాన్స్టాంట్ అటెన్యుయేషన్, కాన్స్టాంట్ డాంపింగ్ రేషియో. సో ఆ టాపిక్స్ నుంచి ఒక క్వశ్చన్, ఈ స్టెబిలిటీ మీద ఒక క్వశ్చన్ కంపల్సరీగా మీకు వస్తుంది అనమాట. సో jury stability test, how this test was done. Let us see how this test was done. Let the characteristic equation is P of Z. Characteristic equation ni P of Z anukundam. So characteristic equation, let it be in the form of P of Z is equal to A0 Z power n plus A1 Z power n minus 1 plus A2 Z power n minus 2 and so on, plus an minus 1 Z plus an. Say this is the standard form of a characteristic polynomial where this a0 is greater than 0. The coefficient of this Z power n is greater than 0. Positive term అయి ఉండాలి. సపోజ్ ఇది నెగిటివ్ అయింది అనుకోండి, ఏం చేస్తాం, ఈ ఈక్వేషన్ మొత్తాన్ని మైనస్ తో మల్టిప్లై చేసుకుంటాం. It must be greater than 0, right? Next, from this given characteristic polynomial, to investigate the stability, there are two conditions. One is the necessary condition and one more is the sufficient condition. And necessary conditions చూద్దాం first. Preliminary test అన్నమాట. Necessary conditions. First one, necessary conditions. First one, this magnitude of an must be less than a0. an is the coefficient, that is the constant term. a0 is coefficient of the highest degree term, z to the power of n coefficient a naught అవుతుంది. Its magnitude, a naught magnitude must be greater than an. అంటే an magnitude must be less than a naught. a naught ఎటు పాజిటివ్ వాల్యూనే, it must be greater than 0. సో an magnitude మనం తీసుకునేది ఇక్కడ, even though it is a suppose minus value ఉన్నా కానీ its magnitude will take. So mod an must be less than a naught. Then second condition, p of z when z is equal to 1 must be greater than 0. P of z when z is equal to 1 must be greater than 0. Next, third one, P of z when z is equal to minus 1. When z is equal to minus 1 must be greater than 0 if n is even. If n is even. What happens if n is odd? It must be less than 0. Z is equal to minus 1 అయినప్పుడు రెండు కండిషన్స్ ఉన్నాయి మళ్ళీ. ఈవెన్ కి అయితే గ్రేటర్ దాన్ 0 రావాలి, ఆడ్ కి అయితే లెస్ దాన్ 0 రావాలి. రైట్? For even it must be greater than 0 and for odd it must be less than 0. So these three are the necessary conditions, right? These three are the necessary conditions. Once these conditions are satisfied, then we will go for the further test, that is the jury stability test. Jury table is to be written here, right? If they are satisfied, form jury table. Form jury table. Suppose out of these three conditions, if any condition is not satisfied, then what you can say? The system is definitely unstable. Out of these three conditions, even if one condition is not also is not satisfied, then you can say that the system is unstable. If only all the if after all these three conditions are satisfied, then only we will go for the jury table. Then how jury table is written, let us see. So again I will write the characteristic polynomial here, since it is in the previous page. P of z is equal to a naught z power n plus a1 z power n minus 1 plus a2 z power n minus 2 and so on, plus an minus 1 z plus an. Right? Now I will form the jury table. So Routh table lagane, but different way lo untundi. See, I will form a table here. This one, z to the power of 0, z to the power of 1, z square and so on, z to the power of n minus 1 and z to the power of n. ఈ ఆర్డర్ లో రాసుకుంటా వస్తున్నాం. z to the power of 0 అంటే కాన్స్టెంట్, z టర్మ్, z స్క్వేర్ టర్మ్ and z to the power of n. నెక్స్ట్ ఇటేమో రోస్ రాస్తాం. రోస్, రో నంబర్ 1, row number 1. The coefficients of z to the power of 0 ఎంత? an. Then coefficient of z to the power of 1, an minus 1. Then next, like this, z to the power of n minus 1 coefficient ఎంత? a1 and z to the power of n coefficient a0. జాగ్రత్తగా వినాలి, మీరు ఏదో ఆన్ చేసేసి అటెండెన్స్ పడితే నిలిపోకండి. సో మీరు పాస్ అవ్వాలంటే ఈ థర్డ్ యూనిట్ నుంచి క్వశ్చన్స్ అటెంప్ట్ చేస్తేనే మీరు పాస్ అవుతారు. See how to form this jury table. First we have written the coefficients from this side constant term నుంచి highest degree వరకు ఆర్డర్ లో రాసుకుంటూ వచ్చాం. an minus 1. You forget, you don't try to by heart as an minus 1 like this. You try to remember the coefficients are written in this order: constant, z coefficient, z square, like this up to the highest degree. Then coming to the second row, you just take the first row and write it in the reverse order. So a0, it means రాసుకుంటూ వస్తాం అన్నమాట. a1, then an minus 1 an. మనం RH క్రైటీరియాలో ఇట్లా ఉంటుంది, డిఫరెంట్గా ఉంటుంది. ఫస్ట్ ఆల్టర్నేట్ టర్మ్స్ రాసుకుంటా వస్తాం, రైట్? ఇక్కడ అట్లా కాదు. విల్ రైట్ ఆల్ ద టర్మ్స్ ఇన్ ద ఫస్ట్ రో, దెన్ ఆల్ ద టర్మ్స్ ఇన్ ద రివర్స్ ఆర్డర్ ఇన్ ద సెకండ్ రో. సో ఫస్ట్ 2 rows మనకి ప్రాబ్లం నుంచే వచ్చేస్తాయి, రైట్? Now coming to the third row. So I will write just only the symbols, then how to calculate I will write the latter. So let it be bn minus 1 and so on. Last one దానికి ముందుది b naught. Then coming to the fourth row, okay, right? First third row గురించి ఎక్స్ప్లెయిన్ చేస్తాను ఫస్ట్. So third row let it be bn. So how this bn is calculated అనేది చెప్తాను. So bn is equal to where bn is equal to where bn is equal to bn. How to calculate this bn? So just take the 2 rows above this row, bn ke above ఉన్న ఈ 2 rows. You consider these 2 terms an a0 and the last 2 terms a0 an. You take the determinant of this an a0 and a0 an. This is bn, right? Then what will be bn minus 1? First element ante rasam idi. Then bn minus 1 is equal to these 2 elements will be like this. Ee column ilage untundi. Then we will come from this last row towards left. Next ee column తీసుకుంటాం. So an a0 and this will be a1 an minus 1. So like this. Suppose next element calculate cheyali, will come the third one. It needs third one anamata. So you try to remember the procedure only. Don't try to by heart this an a0 a1 so and so. You try to remember the procedure. You have to take the first 2 elements and last 2 elements. I have to take the determinant of this set, right? bn up to b0. Now coming to the fourth row is nothing but above again the reverse order of the third row, b0 b1 etc bn. Fourth row మళ్ళీ రివర్స్ ఆర్డర్ లో వస్తాం. థర్డ్ రో ఏదైతే వచ్చిందో దాని నుంచి క్యాలిక్యులేట్ చేస్తాం అన్నమాట. నెక్స్ట్ అట్లాగే ఫిఫ్త్ రో like this up to the last one is 2n minus 3. మొత్తం 2n minus 3 rows ఉంటాయి జ్యూరీ టేబుల్లో. 2n minus 3, say that is some q2 q1 q0. 3 elements ఉంటాయి లాస్ట్ ఎలిమెంట్ లో. లాస్ట్ రో లో you will get only 3 elements. Okay, so these how elements are calculated, how this bn minus 1 or c0 cn minus 1 are calculated, right? So jury's table etla form chesamo chusam. So we have written the coefficients in the reverse starting from the constant to up to the highest degree, and second row in the reverse order. Third row these elements are calculated by using the determinants of these terms. So we have calculated third calculate chesam మనం 1 2 ఇచ్చిన ప్రాబ్లం నుంచి రాసాం. థర్డ్ క్యాలిక్యులేట్ చేసాం. మళ్ళీ ఏది క్యాలిక్యులేట్ చేస్తాం? ఫిఫ్త్ క్యాలిక్యులేట్ చేస్తాం. లైక్ దిస్ ఇవి క్యాలిక్యులేట్ చేస్తాం మనం. ఆడ్ నంబర్స్ క్యాలిక్యులేట్ చేస్తాం ఎక్సెప్ట్ ద ఫస్ట్ రో, మిగతావన్నీ క్యాలిక్యులేట్ చేస్తాం మనం. నౌ ఫ్రమ్ దిస్ ఫర్ స్టెబిలిటీ వాట్ ఆర్ ద కండిషన్స్, హౌ టు ఇన్వెస్టిగేట్ ద స్టెబిలిటీ. ఫర్ స్టెబిలిటీ వాట్ ఆర్ ద కండిషన్స్? లెట్ us check. ఇందాక 3 points చూసాం. Now let us for stability the condition, fourth condition అవి necessary అనుకుంటే ఇది sufficient condition తీసుకున్నాం అన్నమాట. So once this jury table is formed, you forget about the first 2 rows. మనం చేసాం, చెక్ చేసాం ఇది. What you have calculated this bn is there, its magnitude must be greater than the magnitude of the last one. First element magnitude last element magnitude కన్నా ఎక్కువ ఉండాలి. bn must be greater than b0. మరి ఫోర్త్ రోలో తీసుకోమది ఓన్లీ థర్డ్ రోలో మనం ఏ రో అయితే క్యాలిక్యులేట్ చేసామో ఫర్ ద రోస్ విచ్ వీ హ్యావ్ క్యాలిక్యులేటెడ్, ఫర్ దట్ ఓన్లీ we will calculate. then coming to the not for next indulone. Next మనం calculate చేసిన row ఏంటి? Fifth row కూడా మనమే calculate చేస్తాం. Let it be Cn must be greater than the last element C0. The fifth row Cn, Cn minus 1 up to C0. Then sixth row ఏమవుతుంది? C0, C1 up to Cn. So we'll calculate only for the fifth row. Like this, what is the last one? Q2 must be greater than Q0. We will consider only the magnitudes. For stability, all these conditions must be satisfied. So ఇవన్నీ satisfy అయితేనే stability అని చెప్తాం అన్నమాట. They must be satisfied. Right? First necessary conditions check చేస్తాం, తర్వాత ఈ sufficient conditions check చేస్తాం. Now let us take an example, so which will give a clear idea for you. Let us take an example. P of z is equal to z to the power of 4 minus 1.2 z cube plus 0.07 z square plus 0.3 z minus 0.08 is equal to 0. You have to investigate the stability. Given the మీకు characteristic polynomial ఇచ్చేసాడు, characteristic polynomial ఇచ్చాడు అన్నమాట. Then you have to investigate the stability, right? Let us take the solution. What are the necessary conditions? First, the constant term, its magnitude mod of minus 0.08 must be less than the constant of your highest degree. Then constant anta 1. Is it true? Mod minus 0.08 ante enta avutundi? 0.08. So it is true, satisfied. So first is satisfy indi, first is satisfy. Then second the P of z when z is equal to 1. P of z when z is equal to 1. When z is equal to 1, it will be 1 minus 1.2 plus 0.07 plus 0.3 minus 0.08. See, 1.07 minus 1.2 minus 0.13 minus 0.21. So definitely it is going to be greater than 0. So this is also satisfied. Next, let us take the third one. That is P of z when z is equal to minus 1. Z is equal to minus 1 ఇచ్చినప్పుడు 1 plus 1.2 plus 0.07 minus 0.3 minus 0.08. Here n is equal to even. N even 4. So n even అయినప్పుడు ఇది ఏమవ్వాలి? గ్రేటర్ దాన్ 0 అయితేనే. ఈ వాల్యూ ఏమవుతుంది చూడండి, ఇది ఒక్కటే మైనస్, అది కూడా చిన్న వాల్యూ. సో ఇట్ ఈస్ గ్రేటర్ దాన్ 0. ఫర్ n even greater than 0 అయింది కాబట్టి సాటిస్ఫైడ్. సపోజ్ ఇది less than 0 వచ్చింది అనుకోండి, you can directly say the system is unstable. Since for n even when P of z is equal to minus 1, it must be less than 0. Sorry, greater than 0. Even అయినప్పుడు greater than 0 అవ్వాలి, odd అయినప్పుడు less than 0 అవ్వాలి. సో ఇక్కడ ఈవెన్ కాబట్టి greater than 0 నే అయింది. సో they are satisfied. Now let us go for the jury table. ఇప్పుడు jury table కి వెళ్తాం. Jury table. Here how many rows? N is equal to 4. So 2n minus 3. 2 4s are 8 minus 3. 5 rows. 1, 2, 3, 4, 5. Total 5 rows you will get. Z to the power of 0, Z1, Z square, Z cube and Z to the power of 4. So 1 Z to the power of coefficient enta minus 0.08. Z to the power of 0 coefficient is minus 0.08. Z coefficient 0.3, Z square 0.07, Z cube minus 1.2 and Z to the power of 4 is 1. Now write the coefficients in the reverse order. 1 minus 1.2, 0.07, 0.3 minus 0.08. Now let us calculate this third row elements. Third row elements. You consider the determinant of these two. So minus 0.08 into minus 0.08, that means plus 0.0064 minus 1. 0.0064 అంటే 9936 minus 0.9936. Next, coming to this one, second one, we'll consider the first one and the last but one. Right? Minus 0.08 into 0.3, that is the minus value 0.024. ఈ రెండు మల్టిప్లై చేస్తే 0.024 minus of minus plus 1.2. 1.2 plus 0.24. So ఎంత 0.024. This is 1 point minus of minus plus 1.224. That means 1 point. Calculators. Wait a minute, I'll bring calculator. Calculator guy, man. Zero point 0.08 into 0.3, that is 0.024. So this is the value, minus value plus 1.2, that is 1.176. 1.176. Next element. So ఇదైతే ఇక్కడికి వచ్చేసాం. That means 0.08 into 0.07. That is the minus value here. Minus 5.6 to 10 power minus 3 minus 0.07. That means you will get minus 0.0756. 0.0756. Third row, ఇది మనం calculate చేసిన row. Now coming to the fourth row, just take the above row elements in the reverse order. Minus 0.0756, 1.176, minus 0.9936. The fourth row is over. Now again coming to the fifth row, we have to take the determinants of the first one and so ఇవి రెండు multiply చేసుకొని తీసుకోవాలి. So these two multiply minus these two. So if you do, so last one student ఎంత వస్తుంది? I mean I have written the wrong 1.166. So you will get one more element here. I have not written here. మొత్తం ఎన్ని వస్తాయి? 1 2 3 4 రావాలి. 1 2 3 నే రాశాను. Fourth one is minus 0.204. So this is wrong. Minus 0.204 minus 0.0756, 1.176, 0.9936. Right? This is the fourth row. You take the determinant of these two. That means minus 0.99 into minus 0.99 minus even. If you do like this, you will get plus 0.938 minus 1.129, 0.309. Right? So calculator is must for this. So compulsory problem anamata. Right? You have formed the jury table. You see last row lo 3 elements e vastayi. 2n minus 3 మొత్తం 5 rows. Last row లో ఇప్పుడు 3 elements ఉంటాయి. Now check the conditions. So first 2 rows వదిలేస్తాం మనం. Now take the third row. మనం calculate చేసిన rows ఏంటి ఇందులో? Third ఒకటి, fifth ఒకటి మనం calculate చేసాం manual గా. Third row లో first element ఏంటి? What is the first element in the third row? Right? See, third row లో first element ఇది. Last element ఇది. That means mod of minus 0.9936 is greater than mod of minus 0.204. Minus signs కాదు, మనకు కావాల్సింది magnitude మాత్రమే కావాలి. సాటిస్ఫై అయిందిగా. The first element magnitude last element magnitude కన్నా ఎక్కువ ఉందిగా. నెక్స్ట్ ఫిఫ్త్ రోకి వస్తాం. ఫిఫ్త్ రోలో 0.938 mod 0.309. Definitely it is also greater than. So it is also satisfied. So when the conditions are satisfied, you can make a conclusion that the system is stable. The system is stable. We have formed the jury table. Then from this, we have find out the coefficients, whether it is satisfying the given condition or not. Once they satisfied, you can say that the system is stable. Right? System is stable. So let us take one more example. Then with this example, I will stop. P of z is equal to z cube minus 1.3 z square minus 0.08 z plus 0.24 plus 0.24. Check the stability. So first necessary conditions to them. First condition enti constant term 0.24 is less than 1. 1 ne kada ikkada undi coefficient satisfied. The last term coefficient, the magnitude, even though if it is minus, its magnitude only we will take. Its magnitude must be less than the coefficient, which is 1, less than 1. Then second one, P of z when z is equal to 1. ఎంత అవుతుంది చూడండి, 1 minus 1.3 minus 0.08 plus 0.24 minus 0.3 minus 0.38 ఎంత ఉంది ఇది, I'll do 1 minus 1.3 minus 0.08 plus 0.24, that is equal to minus 0.14. See, this is less than 0. Z is equal to 1 అయినప్పుడు greater than 0 రావాలి, but here it is less than 0. So you can say that it is unstable. No need to go for jury table. So in the necessary condition itself, it is clear that the system is unstable. I mean, my video has clicked, I think. Right? Okay, right? We have to check the conditions. If it is not satisfying the necessary conditions, you can say that it is unstable. See, it is less than 0 here. Actually, it should be greater than 0. Actually, it should be greater than 0. Right? Okay. So we'll do some more problems in the next class.